Good morning, good afternoon, good evening, good wherever you are, ladies and gentlemen, and welcome to this SNIA Solid State Storage Initiative presentation on trends in worldwide media and entertainment storage. So today we're joined by two very good guest speakers. I'll introduce them in a second. But just to take you through the interface, first of all, for those of you that have not seen BrightTalk before, it's a relatively simple interface. What you're looking at on your screen just now can actually be expanded to full screen. I do recommend that. If some of the slides appear a little small, the text looks a little small, there is a button there that allows you to expand the screen to a full size. The other two things you have are two buttons that allow you to ask questions, and I'd encourage you to do so during this presentation. If there's anything you don't understand, want clarification on, or you've got a question for either of our speakers, please do so. And if we have time, and there's an appropriate point in the presentation where I can ask a question, then we'll get them answered during the presentation. Failing that, there will be a blog that we'll be putting up at the end, and copies of the slides will be made available at the same place in PDF format. The second thing that we've got there is a rate this button. You can rate this session that we're doing today, and I'd be delighted if not only if you rate it on a scale of 1 to 5, where 1 is, I wish I'd done something else, this was terrible, to 5, this is really good, more of this please. So a scale of 1 to 5, but also any comments that you have about the quality of the presentation, about things you'd like to see us do, and any other general observations that you might want to make. So having done here's the aisle, the lights, the exits, the overwing, etc., let's get on with the presentation today and introduce, first of all, our two guest speakers today. The first is Tom Coughlin of Coughlin and Associates. Morning, Tom.
Good morning. How are you doing, Alex?
I'm fine. So Tom is actually president of Coughlin and Associates, a digital storage analyst and a business and technology consultant. He's over 37 years in the data storage industry, which makes him just about as old as I am, with engineering and management positions at several companies. He does a lot of consulting, publishes books, does marketing and technology reports, including some of the information you're going to be seeing today that he's done. He's a regular contributor for Forbes.com and various other websites, pretty well known. So that's Tom of Coughlin and Associates. We're also joined by Motti Beck of Mellanox Technologies. Morning, Motti.
Hey, good morning, everybody.
So both Motti and Tom, by the way, I think are in Sunnyvale. I'm in the UK at the moment, so if there's a little delay occasionally between the transitions, that long piece of transatlantic wire we're on. Motti Beck is a senior director of the enterprise marketing development at Mellanox, and before joining Mellanox, Motti was a founder of BindKey Technologies, an electronic design automation startup that provided semiconductors and verification solutions that was acquired eventually by DuPont. He's also done a lot of work on Bluetooth, an organization that was acquired by Texas Instruments, and prior to that he was at NatSemi. Motti holds a BSc in computer engineering from Israel. So Motti is actually...
Alex?
Alex, we cannot hear you.
I'm sorry, I beg your pardon, technology break there. Motti is one of these people like me that moved to another distant country to make his living, and apparently he's been the last, goodness knows, couple of decades in Sunnyvale after deciding just to be there for a couple of years. So congratulations, Motti, on sticking it out. So, just a quick SNIA legal notice. This material is copyrighted by SNIA unless we know otherwise. And basically this presentation represents work that we're doing. If you use this information, I'd like you to be aware that we really don't provide you with any warranties, express or implied, and to use it at your own risk. So, what is SNIA? Well, SNIA is the Storage Networking Industry Association with 170 plus industry-leading organizations that specialize in storage and network storage in particular. We've got about 2,500 active contributing members, and we provide information and presentations on technology like this one to over 50,000 IT end users. We also provide, do standards works and also have regular sessions at conferences that we run and other conferences that are elsewhere in the world. So our agenda today is really straightforward. What we're going to be talking about is media and entertainment, in particular the storage aspects of media and entertainment. And Tom's going to take us through that first introductory section. And then Motti is going to talk a little about why we should be considering IP-based rather than any other kind of technology for doing our media and entertainment storage and streaming. And then we'll go back to Tom and he'll talk a little about content archiving and presentation, and we'll summarize at the back end. Please remember as we go through this, if you have any questions, feel free to ask them in the questions box and we'll try and answer them as we go through the presentation. But without further ado, Tom, over to you.
Thank you, Alex. So let's get started here. So first of all, basically everything's getting bigger. The content's created by media and entertainment professionals going to higher resolution. That's kind of what this table shows here, going from top to bottom. Also going to generally more bits per pixel to be able to do higher dynamic range, better colors, etc. As it goes to higher resolution, and this chart goes up to 8K, what's called 8K right now, the frame rate tends to go up to get so you have less visual defects. The net result, higher frame rate, higher resolution, more bits per pixel, the effective data rates go up, and also the capacity generated per hour. So these are some raw rates with certain assumptions. Actual use in practice may differ from this depending upon compression, etc. But the general trend here, for instance, is 8K or Ultra HD content may use more than 170 times the capacity of high definition, for instance, in terms of capacity per hour, and therefore the raw bandwidth. So storage is files are getting bigger, and they're more demanding in terms of performance. And if we go to where this could go in not too distant future, there's reasons to think that we could go beyond 8K. For instance, 16 by 8K, roughly, in those numbers, might be a useful format for video content, especially if I'm doing immersive content with about 8K per eye. So that's basically 16 by 8K for 2 eyes. Pixel, let's say, so if we assume we have 16K content with 24 bits per pixel, things are even more higher definition, higher dynamic range. 300 frames per second raw, because you're going to these higher resolutions, then we would generate about 115 gigabytes per second data rates and 414 terabytes in an hour of time. Now, if we were to try to do an immersive capture with 4 cameras, for example, then we would be creating raw data would be like 1.66 petabytes for an hour of content. So it's easy to see that if I've got a big video project within 10 years, big video project, I could be looking at generating hundreds of petabytes, close to an exabyte of total content for a single, again, big budget project within 10 years, big budget video product. So the data rates are increasing. We're not at the limitations of what people could appreciate in terms of a more immersive experience. And it takes more bandwidth. It takes, as you can see, probably beyond anything we've got right now. And it will also take a significant amount of storage. So this will give us, people will be looking on ways they can do compression and other things as well, try to control this, but despite that, it's still going to grow. So let's look at the elements in the digital content workflow, where it goes from the left-hand side here, various ways in which we capture and ingest content, digital cameras, render farms. Not much in the way of film cameras anymore, but in the past it was, and they would scan those in to digitize it. If you're in a larger facility, you would have some kind of shared storage you'd be using, probably at the local level, to do your, in the middle, the post-production activities, which includes nonlinear editing, compositing, color correction, and finally conform and assembly. Once you've got a completed project done then, you would oftentimes transcode it so you can digitally transmit it with the desired characteristics on various distribution channels, which could be broadcast, cable, satellite, or over the internet, and also perhaps in a digital form, maybe shipped in a hard disk drive or something in a Pelican box to a digital cinema. And finally, because this content has long-term economic value, it would end up in an archive, backed up during the course of work, and then finally in an archive for long-term preservation and reuse for later on to make more money, presumably. So Coughlin Associates has been doing a survey of professional media and entertainment, or media entertainment professionals rather, since 2009. And we looked at all the use of storage and all different aspects of that workflow. If we focus for a couple of slides here on the content acquisition side, in particular on the cameras, the 2018 results on the media that people are using for their cameras is shown there on the left-hand side. That was about 56% flash memory, about 35% hard disk drives, some film, some magnetic tape, and some optical discs. But flash memory was the majority. And in fact, if you look at the history on the right-hand side there in that table, flash memory has generally been growing in terms of its use and has been the majority of camera storage media for some time. The hard disk drive side of it probably is for in-studio type recording versus in the field, because flash memory being more rugged tends to be used more in the field and even in the studio for that matter. Film in general has gone down, although 2018, just based upon who we were surveying, we saw some bump up apparently in that. Magnetic tape has gone down and optical has gone down, but flash memory and hard disk drives are still pretty important for that content acquisition. If we look at another slide, again, this is some survey results here. On the right-hand side, we show the hours of content shot with the camera for 1 hour of completed video in 2018. And to summarize some of those results, in our survey, 51% of respondents said that they captured 6 hours or more of content for 1 hour of finished work. And 77% said more than 90% of their content was born digital. You can see some of that percentage born digital from 2010 to 2018 in the table on the left-hand side. In general, a great majority of content is digital from the get-go. And finally, in addition to the survey, we also use that to inform a report we've been doing on pretty much an annual basis on digital storage, use and projections in professional media and entertainment. And on the acquisition side, here is a chart here on the left side that's looking at in various types of content acquisition, different movies, broadcast episodic, for example, and projections of their growth from 2017 to 2023 in the 2018 report. And we're projecting that we're approaching 70 exabytes of storage capacity used for content acquisition and creation. That is new purchases by 2023, and that's about a 4.5 times growth from 2017. So once we've captured the content, then we need to do what's called post-production. A very important step in that is nonlinear editing. It's nonlinear because digital content, you don't have to follow a film in editing something. You can move back and forth from one part to another. In general, this is done at a workstation, although there are some online technologies out there for doing this directly on the cloud. For the most part, people do this on a workstation or a laptop or other type of computer with local DRAM memory, that is, and also local storage. It's become very common, since many projects are collaborative projects, then to have that connected perhaps to a local network through some kind of a card, a NIC card, as we show here, and maybe access block-based data through a SAN, block-based video data through a SAN, or where the file system is in the video editing station, or directly from the file level in a NAS. It also is becoming, as we'll show in the presentation here, increasingly common to use external database resources, which might be a private or public cloud. In fact, these are in the collaborative, in the nonlinear editing, a lot of collaborative projects are done using the cloud for distributing the content that then is worked on locally. Now, an interesting thing here, as the data rates are going up, requirements for this content, that flash memory, especially using the higher speed NVMe interfaces, is becoming more popular in editing and starting to displace hard disk drives for that primary editing storage. And we expect that trend to be increasing as we move into more and more of this higher resolution, higher frame rate content. Also from the report, here is some projections of post-production storage demand, breaking it down by the cloud and local network and also local storage. And you can see the increase in the total capacity there in our 2018 report. And in the survey, we found that 48% said they use cloud-based storage for editing post-production. And 56% of the participants said they had 1 terabyte or more of storage capacity in the cloud. Okay, so we've captured the content, we've worked on it and made it ready for use, come up with our final conform and assembly of our final copy, master copy. Now we want to get it out and monetize it. So there are many ways of distributing content, of course, from digital cinema, where oftentimes things are shipped, possibly satellite, but mostly where you ship a storage device with the content on it, to various ways of providing content over the internet. One of the most common ways, which has been around for some time, is called the Content Delivery Network. In fact, there are even cloud-based services that offer this as one of their services. Once people get their content in the cloud, they want to distribute it from the cloud. So the way a CDN works is I've got a central content server of some sort, which I have a library of content behind that. And what happens is that the central server, depending upon traffic, will pre-populate content on the edge server, and that way it's and deliver that content directly to the end users. Now, having it distributed to the edge server reduces the bandwidth requirements and the back and forth traffic on the central content server. It also provides lower latency content from the to the end users, so they have better satisfaction, they have better bandwidth characteristics, and it doesn't bog down the content, the central content server, which is serving out to the edge servers. And a final slide then on the content distribution. This again is from the survey work. In 2018, 39% of the survey respondents said they use flash memory in their central delivery servers. You can actually see that some of those trends on there's a table on the upper right side. High-speed enterprise solid-state drives and other solid-state storage technology was about 48% usage in 2018. Again, that's in that upper right-hand box. You can see some of the history. And in 2018, internet distribution was the most popular way to view proxies. Proxies are a low-resolution version of a piece of content sent out to folks for editorial use or for approvals of content as you go through your video project. So that's some of the trends there. And with that, I'm going to turn it back to Alex, who will bring Motti in here to talk about IP-based video. Thank you.
Thank you. That was very interesting. One question I do have for you. I'm really surprised that tape has declined so dramatically and quickly over the previous few years. I mean, I would have thought the byte cost for tape was a lot less than any other medium.
So I'll be getting more into tape a little later on when we get into the archive session. The tape that I was primarily talking about here was tape used in cameras. So the digital tape used in camera has been going down in, at least in terms of surveys, going down in its popularity over time. I guess it's just easier to use the flash memory. It's rugged. And as the costs have gone down, it's become an effective storage media. But I agree with you, the tape used in those cameras would be inexpensive. But I think because that content has such value, the convenience of flash, or the convenience performance of flash, or the combination of cost versus performance trade-offs and hard disk drives have especially for in-studio work have predominated, and tape has been declining for those applications.
Yeah, and I suppose it can be dumped off pretty quickly from cameras onto, away from the edge and on a regular basis. Okay, yeah, I get that.
It can be. There's one little piece of that, though, that's still there, is that a lot of times these big video projects, especially movies, are funded by a consortium, and those consortiums often require a bonding process for the video. And part of the requirements, essentially insurance, and part of the requirements are that you make an immediate backup of content. And there are a great many devices for backing up onto, for instance, an LTO tape as you capture the content or very shortly thereafter. So there is an application there on tape, which, this still is a very popular media, fairly good popular media for doing that, if you will, immediate archiving application.
Yeah. Okay, thank you, Tom. So let's talk a little about IP-based video and why you should be considering IP over anything else. So just to reintroduce again, this is Motti. Motti's going to from Mellanox. He's going to take us through the IP-based approaches we should be taking. Motti.
Okay, thank you, Alex. And I would like also to thank Tom for an excellent overview about the industry, because this really makes my job easier to understand why actually the industry is moving to an IP-based video compared to the technologies that are available today. And all we know that, we all know that today the video becomes a very important part of the communication, and more tasks and communication are being done through video. Industry or numbers in the industry show that more than 70 or 75% of the internet traffic is actually video, and actually it's expected to grow. And to show the challenges, actually, I decided to take, I believe, the first slide that Tom showed and to visualize it, because visualization showed the big increase of the need for more storage and higher performance networking when we are going to the next generation. On the left side, you can see just the increase of the higher resolution. But the higher resolution moving from 720 to 4K and in the real near future to 8K, it's just one parameter. If you add to that the number of bits that you need, the depth, mean how many bits you need to save for or to store for the different colors, and also the gamma correction and the frame rate that running today from 60 to 120, you can get the massive amount of data that is moving. And all the numbers that I'm mentioning here is uncompressed, of course, but even if you compress it, there is a very a high demand for a higher performance networking and, of course, the storage as well. So the industry today actually is using technologies. There is technologies today that are being used, and most of them are being used on using the fiber channels for storage and serial digital interface, or the SDI, that is a very old but being used for many years for the traffic itself. And the industry must need now to find a better or more efficient or fastest way, cheapest way to transfer and to do the job. And nothing is better compared to than to use the Ethernet. Today you can get for less than 200, or let's say less than 300, up to 25 gig per second. You can use it, and there is nothing better than used to do it. So why to use two different technologies? Why? Or you can use only one of them, which is the Ethernet. There are today, the Ethernet is already moving to 100 gig per second. That can 3 times the fastest way of the transfer of over fiber channels, which is about 32. And actually there are solutions today that are 200 gig per second. The Ethernet is commodity, tools are free, and workload are that you can run, you can scale it very easy. So this is actually why the industry decided to choose the Ethernet or the IP as the IP-based technology or networking for the next generation. And just as a comparison to why IP is so much better, on the right side you can see the traditional SDI or the serial digital interface solution. Every time that you need to add another stream, you need to plug manually another cable, and to run it from the producer to the consumer, let's say. It's a coax cable, very heavy cable. The installation is labor intensive and pretty hard work to do if you want to meet, of course, the new demand for the next generation. So this, the industry came together, worked on the industry standard, the SMPT 2110, that runs over IP, run over Ethernet, cheaper, commodity, single cable, mostly optical. If you want to run on a longer distance, of course you can do it over copper, but copper is a very short distance. It's light, flexible. The communication can be, upgradable, future-proof, and automatically controlled and managed. So you can really see here in a very easy way why the IP is much more better or more efficient and can provide the need for the future. By the way, if you guys are going to be at the upcoming NAB 2019 in Las Vegas week after next, I believe, then you'll see, I believe, several systems that are already running over the new protocol, the new standard, the 2110. So it's already started, and all new deployments, whether it's in the cloud or in the enterprises or in the private offices, I would say, already deploying the IP-based solution. But when you deploy an IP-based solution, you need to take into account a couple of parameters into account. One of them, of course, you need to choose the right technology or the right speed to support the growing demand for the bandwidth. I put here, I know that it's a little bit busy slide and not all of you can see all the numbers, but if you are moving from 4K or moving from high definition to 4K, there is about 4K higher demand for bandwidth. There is also the gamma correction and the frames per second. Everything is about higher bandwidth. Take into account on the right upper side, if you can see it, there is a table that compares the number of streams that you want to run sometime, specifically today with all the movies that you want to stream online. Then you can see that it's pretty much growing very fast, that even the 100 gig may be not enough. So when you are choosing it, the right technologies, I would suggest to choose the highest performance from the bandwidth point of view for future-proof, and because the demand is, as I mentioned before, and we all know, is just going to grow more and more, not just from the bandwidth, but the quality and the frame per second, everything that we mentioned. So one parameter is the bandwidth, but another parameter is actually the latency itself. Tom mentioned the growing use of flash-based memory and on the storage, and on the left side you can see a scale that actually compares the different the different latencies that the different storage technologies are using. When you were using hard disk drive, the latency was 1 millisecond, and now when you are going into the flash, you are talking about now less than 10 microseconds. And I believe that with the upcoming persistent memory, and actually it can go down to the area of 1 microsecond as well. So you need to take into account the trend on the latency itself. And if you just use the traditional IP or Ethernet switches or NIC, they pretty much can support, I would say, that today SSDs actually they are a little bit too slow to provide even the Optane type of the flash memory, and of course are not going to meet the persistent memory. So you need to choose the technologies that actually, and there are technologies today that can support much lower latency. Choose the right NICs that can have the lower latency available, and also switches. If you are taking Ethernet switches, it's going to be good to compare the latencies that can run sometime as low as 300 nanosecond, but if you're not going to be careful, you can get one that as 1 microsecond. So the overall efficiency, yes, it's going to work, but the overall efficiency is going to be much lower. And also, sometimes it's not just to one hop in the communications. There are several layers of switches, so it's going to accumulate. Take a look also on the management. I'm going a little bit deep dive into the switch itself, on the policy of the buffer management. In each one of the Ethernet switches, there is a big buffer, and sometimes the management of the buffer is not very efficient, and there is blocks, unnecessary blocks that are available or created through a specific traffic. So again, be very careful when you are choosing the right gear to the next generation when you are using or deploying the IP. Also, another way actually to accelerate, and this is technology that became recently very, very popular in the industry, which is the RDMA technology that runs over Ethernet as well. This is RDMA stands for Remote Direct Memory Access, that in a sense actually offloads the transport task from running on the CPU itself to run on the NIC. If you'll take a look on the left side, I'm illustrating a traditional or a standard TCP/IP that requires several copies on the transmit side and several copies on the receive side. Actually, in addition to that, it's using the operating system to do the tasks, and every time that you are using the operating system, you cannot know exactly what the operating system does at the same time, so the latency can be higher or lower, so the jitter is going to be unpredictable. This is actually, usually I'm using an analogy that it's very similar to doing a business between us directly, instead of in parallel to doing a business between us through the government. So if you can avoid the government and you can avoid the operating system, and this is what RDMA is doing, it's going to be much better and higher performance solution. RDMA runs on a user mode. It doesn't need the operating system. What the CPU needs to do is to tell the controller, the I/O controller, move this block from this side to the other, let me know when you are done. The controllers are communicating directly between the two of them, so the CPU is actually not involved, and the cycles that are usually taken by the TCP/IP task are freed up to run the application, which is more efficient way to use the CPU. So RDMA became recently a very popular, actually, we saw many times that it became actually a checkpoint when you are deploying a new data centers in general, whether it's a cloud or enterprise. There are solutions today on the storage, whether companies that are coming with hyper-converged solutions that runs over RDMA, over Ethernet, the standard called RoCE, like Microsoft S2D, or even VMware announced recently, did a preview of their vSAN over RDMA, and NVMe over Fabric. I believe that all of you, or most of you, are aware of those technologies. So I would recommend to choose a NIC that can support the RDMA, that is going to be future-proof and is going to be a way to create a higher efficiency. In addition, there is also sensitivities. You can should be very sensitive to how much CPU you are taking when you want to run the 2110 standard. This is like a chart that shows how much performance you can get out of one core of a CPU. So if you take a look up to, I would say, 4K, you can probably run it, the 2110, specifically the packet pacing, which is the 2110-21 standard, over one core. But when you are running higher resolution or more frame per second, you start to see that one core is not enough. and you need to use more of the CPUs. And there are today in the industry NICs or network controller, Ethernet network controllers that can support the RDMA and can support offload capabilities to run those tasks in hardware as much as you can to offload the task to the CPU, from the CPU to the network, is going to create a much efficient and cheaper and robust solution for the new generation storage and the overall video infrastructure that you want to build. So in summary, I would say that, again, be careful when you are choosing. The IP is here. It's going to be the standard. 2110 is the standard. All the industry and the big players are behind it. But when you are choosing the right, choosing the IP technology or the component, be careful when you are using the Ethernet video fabric on the deployment of it, that is going to replace, again, the SDI. Choose the right component. Be aware of all the little different things that may affect the performance and the efficiency. And I believe it's not too complicated, but once you are going to do it, you are going to be safe. So this is going to be my last slide, so I'll bring the mic back to Alex.
Thank you, Motti. I've got a question for you. In fact, I've got a question for both of you. It's come up from the audience. Remember, you can ask questions here and we'll answer them. So this is one that's just come up. Are there any media and entertainment specific performance benchmarks or other qualification tools when looking for storage subsystem? I mean, we've talked about performance here on the network side, you know, and there are different aspects like the content delivery network and video editing. But are there any benchmarks that you can employ for doing perhaps end-to-end stuff or looking at, you know, assessing storage?
Actually, I'm not aware. Maybe they are. I'm not aware of it. So let me you know, take it offline and then we'll publish it later. I'm not aware, unfortunately.
Okay. No, that's fine. That's fine. Thank you.
There may be some. This is Tom. You know, I know there are some benchmarking and tools out there. I just can't remember the right offhand, but yeah, we can probably answer that later. There may also be some things. There may also be some things within SMPTE that could be used for some benchmarking. But again, I have to go check.
Yeah.
Yeah, that's something. If we got any information, we put it together. We can put it on the web, on the blog. That would actually be quite interesting. So yeah, we'll answer. It is a good question. Very good question. The other question that I have here, I'll wait until we get towards the end because I think it's more relevant there. So, without further ado, just let me move this slide on. And Tom, you could take the back end of this session tonight.
Indeed, we shall preserve the results of the earlier stuff. Sorry. So, we now talked about content acquisition, post-production, delivery, and then we looked at the movement of a lot of these operations to IP-based workflows. The final end of what we do in media entertainment is we keep the content because it has economic value that lasts a while, and therefore we want to preserve it and keep it viable and keep it as high a resolution form as we can. So this involves using low-cost, high-capacity storage media. Examples of that are shown here: magnetic tape, optical discs, and hard disk drives. And going back to our survey again, looking at percentage of digital long-term archives in various media. That's what's shown here on the right-hand side, the 2018 survey results. And what's interesting, actually, the last couple of years we've done this survey. Prior to that, digital tape had been the majority. And maybe depending upon the people that were doing our survey, external hard disk drives actually in 2018 were the majority, and the year before as well. In 2018 it was about 54%. Digital tape at about 25%. So there's a lot, at least for the people who are taking the 2018 survey, there were a lot of folks who were using hard disk drives for a more active archive versus digital tape, which has generally a little bit longer time. And by the way, for those that are interested, that survey is still going. In fact, you go to the tomcoughlin.com website and your media and entertainment professional, be great if you could take our survey and give us your input here. Of the magnetic tape, about 74% of the digital tape that's used for archiving and media entertainment, according to the survey participants, is LTO tape. And there is a growth in public and private cloud storage for archiving among our participants. And 32% of the participants in the archiving side had more than 2,000 hours in a long-term archive, and some a great deal more than that. There were some survey results there. We got some additional survey results here, as well as some material from the report here as well, projections in archiving, and also what I'm calling content conservation and preservation, or conversion and preservation, rather. So the annual conversion rate from older analog content to digital content from the survey still seems to be about 4%. But the conversion to digital content has been underway for some time, and at this point in time, it's not. I think it's going to start where it has been a big driver for the total archiving content. I think it's going to be a less of a factor going forward. A lot of the content that was going to be digitized already is, and that's why in the graph on the left-hand side, you can see that the conversion and preservation over time, we're seeing that as being less demanding annual archive capacity increases versus new content. Of course, new content, as we said before, is getting larger, and so it's will assume a bigger part of the total archives. So anyway, it's driving overall the archive growth, as you can see here, is growing, and a lot of that's driven by this conversion and preservation, and a lot more of it going forward by the generation of new content, which then has economic value and will be archived. We talked a bit about the cloud in various ways, and so here's a chart from the report on the right-hand side that looks at different aspects of that workflow and the amount of projections on the growth in cloud storage. That is in terms of the overall revenues. And we actually are projecting somewhere north of $2.5 billion in 2023 of cloud storage revenues for all these media entertainment applications, going up from 2017 at about $500 million. In the survey, we found that 77% did product distribution through the internet. I think we mentioned that before. 6% said they archived on a private or public cloud, and 66% said they would use a private or public cloud for archiving in 2018. And we're now doing the 2019 survey, so we'll know on those results probably by May. And in general, cloud storage for the archiving applications and these others are growing. As you can see, the result of that will be increase in total revenues going into private and public cloud storage. Now let's look at just kind of to wrap up this talk here. Look at the distribution of storage capacity depending upon the various operations in the workflow. The largest capacity is in this archiving and preservation at about 77% in 2018, followed by post-production, content acquisition, and content distribution. And that's because the archiving tends to be these really big files. On the other hand, if we go to the right-hand side and look at the revenue spent in 2018, although it's 77% of the total capacity, it's only 35% of the total spend on storage. That's followed by content distribution at 33%, post-production at 27%, and acquisition at 5%. And looking at the types of storage capacity overall in 2018, hard disk drives, about 71%, the majority. Tape at 22.7%. So, Alex, tape is still a pretty strong component, especially when you get that archiving activity in there. Followed by flash at 4.3%, optical at 4.3%, and flash at 2%. Now, let's look at the flash in particular. Well, all the different revenues share from 2017, where we show hard drives at 81%, flash at 14%, and tape at 4%. Going out to 2023, hard disk drive declining a bit in terms of the overall percentage of the revenue, going to 71%, with flash increasing now from 14 to 27% because of the increasing demand for higher performance and lower cost of flash, and tape declining as a percentage of revenue by about 2% here over that time period. And looking at where the flash should be used, the overwhelming majority by 2023 we expect still will be an acquisition at 71%, followed by post-production, 21%, and video on demand, various types of content distribution at about 7%. And our survey shows that about 56% of the survey participants use flash memory, their camera media, reminding you of that again. And this flash in post-production is growing in 2023 over prior years. And about 39% use flash memory on their edge servers for the content delivery networks in 2018. So again, to summarize here, here's some of these big trends: that the increasing resolution, higher dynamic range, higher frame rate, multiple cameras will drive media and entertainment storage demand and impact every element of the workflow. That will require some higher bandwidth applications increasingly. For instance, in post-production, flash memory use will grow, both because of the requirements and also because flash memory will continue to increase overall price declines over time. Cloud storage, storage in data centers, which may be public or private, will play an increasingly important role in all aspects of professional media and entertainment, from content creation on the rendering side for sure, through collaborative workflows on the post-production side, and finally into a growing amount of archive content, which is in the cloud. And what this means is, in addition to flash, all the other types of storage still have a place for at least the near term. Hard disk drives, optical disc, and tape will still serve as a bulk storage role, where you don't have quite the performance, but you're looking at a lower cost for storage. So with that, I've got some references here I can show you to show you this 2018 survey, Storage Professional Media and Entertainment. There's a copy of the higher level report on our website. We're also the same site where we talk about the Media and Entertainment report itself. And then also, just to remind you again, the NAB show is coming up in just a couple of weeks. So with that, I'll hand it back to Alex, and maybe we'll answer some more of those questions.
Thank you. Thanks, Tom. Yeah, the NAB show, I think, is April 6th through 11th in Vegas. It's quite an interesting website. It's very graphics heavy, as you'd expect. So the question I have, I'm going to try and interpret this question because I'm not 100% sure I've got enough detail here to fully understand it. But so the question I suspect is to do with revenue, or rather expenditure, on various storage types over the coming years. Are you expecting to see an increase in the overall revenue in terms of the spend, or are we looking at such a fast decline in the per byte cost of storage that you expect the revenue to flatten or decline?
So I think the big answer to that is that I think demand is growing faster than the price is falling. The total capacity demand is growing faster than the price of bytes are falling for any of these media. And so I think the net of it, and the reason why is because there's a lot more content being made. It's becoming higher and higher resolution, particularly on the master copy, and higher frame rates. Generally, it's getting cheaper and cheaper to do better and better things, and so people are doing that. So the price is declining enough to encourage people to make higher resolution, higher frame rate, higher dynamic range content. At the same time, the prices are not declining so much as to make them spend less overall. So I think there's a general upward trend in terms of the spend and in terms of total capacity under management.
Okay. And I suspect the same Motti of network. Are we looking at an increase in expenditure in terms of network, even though our latency is dropping and our bandwidth is increasing? I think so, Alex. I think sorry. I think our overall overall need, or let's put it this way, we've not reached the limits of the enhancement of human experience and creating immersive experiences. And until we do, I think that we will continue to see, and I think that's something that is very much a pull in this industry. And until we reach a saturation where we basically can't make it any more real,
we haven't achieved the holodeck yet. Until we make a holodeck or something like that, I think effectively we're going to keep on increasing the storage capacity requirements, if you will.
Yeah, you're gonna scare me now. Holodecks are just Anyway, so one of the other questions. This is quite a good question. You said 66% or 2/3 are going to be using private or public cloud in 2018 and onwards for storage. Have you got a split between private and public, or is that really not a relevant figure these days?
Well, it's an interesting question because this is an industry which has security concerns. You know, if their content has a significant value, there certainly is I think a lot of the and what's going to be the split? They may use some public cloud for some things, but what do they keep everything on there? I think there's some resistance to that in this industry. I think a lot of this will be on the private side, although there is a growing use for some functions, certainly, with the public cloud. Rendering, for instance, is a very popular thing to do in the cloud. Building a render farm is pretty expensive. If I can just rent it out and use it to create content, that's very cost effective. So I think it's going to vary depending upon the application. And will I, for instance, archive and keep all my content long term in someone else's cloud? And some might be kind of nervous about that. So I think it's going to be a lot of private cloud in this industry with some use of public cloud. But as that's of course that may change over time depending upon what people are able to do with public cloud, what the costs are versus doing it locally, etc. Yeah,
but by the way, the borders, I would say, between the public and the private started to be unclear recently. There is some sensitivity, of course, as you mentioned, about having your data on a public cloud. So this is actually why companies or public or cloud service providers started to offer the enterprises to have on-premise their own cloud. So in a sense, if you saw recently the announcements that all the big guys were doing, whether VMware, Oracle, or even Microsoft, they have what they call a standard that you can build a system that is 100% compatible with what their cloud provide. This is what we call the, like for example, Azure Stack, for example, or the Dimension from VMware. And then you can build it. The managements are the same. It's being managed by the cloud service provider, but it's on-premise. So how you define it, whether it's private or public, this is really hard to say now.
Yeah, it's getting pretty blurry. I'm seeing more and more of that, actually, where people are talking about cloud, and then you suddenly realize that they're in this, not only are they talking about this hybrid arrangement of local data center and remote third-party provider, but they're not even able now, a lot of them, to differentiate what is where to a large degree because of the nature of the compatibility between the two ends of the bits of wire. Yeah, that's a really good point. There's one question we've been asked that I can actually answer. With regards to hard disk storage, does the interface trend continue to be SATA and SAS? And the answer to that one is really straightforward, and it's nothing to do with media and entertainment. Is not. It's going to be NVM, non-volatile memory express, and everything over fabric. So I think we're seeing move away from SATA and SAS. A bit slow. It's going to take time, but we're going to see a move away from that as a particular interface. And does the back-end workload look to benefit from SMR or dual actuator technology? Those technologies are all about huge capacities and dreadful performance. Well, not dreadful, but not terribly great performance. And they are more suited to archive. And archive is a peculiar beast, and I think we're going to see an awful lot of high density, but I don't think we're going to get to the point where more than around about 30, 35 terabytes per drive in the next 5 to 10 years or so. I think we're coming to a limit of where we can stick in a drive, regardless of whether it's SMR. And dual actuator doesn't really help. It does give us two paths to the data, but it's not really helping with density or performance for that matter. So, thank you very much indeed, gentlemen. I'd like to thank both Tom and Motti for their really good presentation today. My apologies if you've had problems with the sound. I had a little bit of a technology glitch. As you all know, technology is for selling, it's not for using. Unfortunately, my headset disconnected from my phone fairly early on in the presentation, for which I apologize. But on the way out, I'd just like you to note that we've got a blog address there. We'll post up this presentation in PDF form and also a question and answers. All the questions that we had today and the answers will be posted up so you can read them. So apologies if I didn't get to your question. And on the way out, if you could simply give us some feedback, rate this presentation. It's immensely helpful to us. Nobody's job's on the line here for this, but we really are interested in what you think of these kind of presentations, the content, and any comments that you have would be greatly appreciated by me, by Tom, by Motti, and by everyone at SNIA that's involved in providing these educational tutorials. But in the meanwhile, thank you very much, Motti. Thank you very much, Tom. Thank you very much to our audience. And please enjoy the rest of your day. Thank you for attending. Bye just now.